Hello everyone, welcome back. Here is Ali Talabi and this is the third lesson from module 18, interest rates. So in this module, we'll have two major topics. We'll talk about theories on the term structure of interest rates, and then we'll talk nominal and real interest rates. So let's start our session. So in the previous lesson, I talked briefly regarding the term structure of interest rates, and I mentioned that it is showing the relationship between the time to maturity and the interest rates. Usually, the relationship is positive for the longer term expiry date or maturity date. The interest rate is higher, but we also see in some cases that this relationship is inverted. Or it's negative. The term structure is also called zero coupon yield curve, and if you hear about the yield curve, is the concept is same as the term structure of interest rate. The yield curve also is showing the connection, the relationship between the maturity and the yield on a specific securities. Most of the time, the yield curve has a positive slope, but in some cases, again, as I mentioned before, we see inverted yield curve in which for the longer term securities, the interest rate is lower than the shorter ones. This is a very rare situation. Most of the times we see the positive slope yield curve. There are several theories regarding the term structure of interest rates. I'm going to address two major of them here. The first one, which is kind of, I would say, the most important one, is called expectations theory. Expectations theory actually argues that the term structure of interest rates demonstrates the financial market's beliefs about future interest rates. So it's all about expectation. It's all about beliefs of the future interest rates. This kind of argument is a kind of important. Why? Because this approach will help us to determine the forward rates in the market. In other words, we can say the forward interest rates show the market expectations of future short-term rates. I will provide more information regarding the forward rates in the following next slide, and I will show you some examples how you can actually use the forward rates formula to calculate the future short-term interest rate. The second approach is called market segmentation theory. The argument here is that the market or the debt markets are actually segmented based on different maturity dates. So they are segmented based on the expiry or maturity dates. So interest rates for various maturities are determined separately in each segment, and for sure it is based on the supply and demand. The yield curve, which we mentioned earlier, is determined based on the supply and demand for debt instruments for different maturities. So 1 year versus 5 year versus 10 year, depending on the maturity you're talking about. The interest rate will be determined on that specific segment or market. From now on, the focus will be mainly on the expectations theory, and as I mentioned, I'm going to talk more about the forward rates. So we can use the expectation theory to calculate the implied forward rates. So if the short-term interest rates are determined based on the expectation, so we can calculate the forward rates now for some time in the future. Again, the forward rates, you're talking about the rate which will be in the future, but you are going to determine the rate now. That's why we call that forward rate. So again, the forward rate is showing the expected rate on a short-term security that is to be originated at some point in the future, but you know that from now. We use this formula to calculate the 1 year forward rate. So for example, if you know the 2 year interest rate, if you know the interest rate for 2 year, you should be able to calculate the interest rate for 1 year and the forward interest rate for the future. In other words, the 1 year annual interest rate 1 year from now will be based on this forward rate. To explain this notion, I'm going to provide you an example. to see how actually we are going to calculate the forward rate. And here you see I'm using a forward rate of 1, comma 1. What does it mean? The first one is actually referring the 1 year period, so it's starting 1 year from now, and the second one is actually is showing that for how many years you are going to expect or calculate the forward rate. So that's the forward rate 1 year from now, and it's for 1 year. Now let's look at the example to explain this concept. Let's assume that you have the 2-year rate as 10%. So when you're going to invest in a security, that's a 2-year, let's say, investment, and on each year you receive 10%. That's a 2-year rate of 10%. The 1-year rate is 8%. So if you're going to invest in 1-year security, let's assume that's 8%. The question here is, what's your forward rate? You have to be careful with the rates. All of them are on annual basis. The 10% is for the 2-year investment. On annual basis, you will receive 10%, and the 8% is just for 1-year investment with 1-year rate of 8%. So using the formula we mentioned, you can actually calculate the forward rate 1 year from now for 1 year. So I just plug the numbers and I get just over 12% my forward rate. So since you see that's the regular normal yield curve, since your 2-year interest rate is 10% and the 1 year is 8%, you should expect the forward rate of greater than 10%. That's why the average or the total comes to 10%. So the forward rate will become just over 12%. Let's look at another example. So let's assume we're talking about the 3-year rate. The 3-year interest rate is 10%. Again, you will receive 10% on annual basis if you invest on a 3-year investment. And let's assume the 2-year rate is 8%. And based on this, we're looking to calculate the 1-year forward rate. 2 years from now, that's the argument. 2 years from now, what will be your forward rate? So because that 8% we mentioned, that's a 2-year rate. So the first year becomes, so let me just show you here. If you go with the timeline, you see that, so it's year 0, year 1, year 2, year 3. So you have the 2-year rate of 8%. So 8% is here, 8% is here. The goal here is to find here, you want to find the forward rate 2 years from now for the next 1 year. So that's why I'm saying F2, 1. So F21 here, it means forward rate 2 years from now, and you are going to calculate for the following year. So using the same formula, this time just be careful with the power. So it's 1.1 to power of 3, 1.08 to power of 2, and the forward rate here becomes 14.11% almost. So you should expect to have the forward rate of 14% 2 years from now, based on that 10% 3-year rate and 8% 2-year rate. Again, this is a kind of the normal yield curve. As you're moving forward, you expect to have the higher interest rate for the longer period maturity. Now, the last topic I'm going to mention is regarding the nominal versus real interest rates. We had this conversation before, and I mentioned that sometimes you hear about the real rate or the nominal rate. The major difference is actually related to the inflation. So you have to adjust the investment rate or the interest rate based on the inflation. So maybe you say, Ali, what is the nominal rate? Nominal rate or nominal interest rates are those rates which are observed, which are quoted, and you don't adjust for the inflation. For example, if you go to your bank and if you have a GIC investment, or if there is a CD, we talk about the CD, certificate of deposit, or GIC, guaranteed investment certificate, so you can actually invest and there are guaranteed return. You will receive a quoted rate. For example, you will receive 2% on annual basis, but that 2%, that's a nominal rate. That's a rate you have to adjust for the inflation. If the inflation is 3%, not only in this example you are not gaining anything, but also you're actually losing money, almost 1%. You're losing 1% because the inflation is greater than the quoted rate. So this is the formula we use to calculate the real interest rate. This is the approximate version. So you can use this formula to calculate the real interest rate. I'm saying that approximate version because we can calculate exactly the exact real interest rate, and I'm going to mention that in a second. So I mentioned that the real interest rate is different than the nominal interest rate. The connection is actually is mainly described by something which is called Fisher equation or Fisher hypothesis. The idea here is that the nominal interest rate and the inflation are related. Now, how we can exactly estimate the real interest rate? The real interest rate is calculated based on this formula. Real interest rate is 1 plus nominal interest rate divided by 1 plus, I'm going to use pi, the Greek letter, which is usually used to show the inflation. So pi here is showing the inflation rate minus 1. That's the exact version versus the approximate version we mentioned earlier. For example, if you expect to receive 10% on your investment, and let's assume the inflation is 5%. If you go with the approximate version, it's 10% minus 5%, so your real rate here becomes 5%. However, if you go with the exact version, so let me just calculate 1.1 divided by 1.05, it gives you almost 4.76%, which you can see it's less than 5% approximate version. This is more specific, more exact rate, and in this case you are actually including the compounding factor. That's why I personally prefer the exact version than the approximate version. That's how we calculate the real interest rate using the inflation and nominal interest rate. Well, that's it for today. Thank you very much. This was module 18, and we'll talk about interest rates. I will come back with some questions from this module, and I will review some major notes. Have a wonderful day. Talk to you soon. Here is Ali. Take care.